Today is the 20th of October 2023, and I'd like to introduce you to the topic bearing, okay, in maths, okay, and this will be our first lesson. I'm hoping to do a couple of bearing lesson to introduce you and to look at some questions with you. Before I begin, thank you to everyone who has been helping watch our videos. If you haven't subscribed already, please can you subscribe, share, like, follow, etc. Okay, if you subscribe, you can share, you can also like, you can follow on other platforms as well. Okay, I'll really appreciate that. I normally write, please follow my notes/scripts in the comment section. Okay, this is maths. At times you might be carried away, and then you are trying to talk about rectangle and you say triangle, or triangle and you say rectangle. Okay, these are just simple questions, things. If I want to edit all those out, I might not be able to show you the whole question, or I have to do it again, and the probability of making such simple mistakes, maybe having that slip of tongue at that moment is there. So it means I'll have to keep on recording. I will never have a video. So I just put it out there and ask you to follow. So for instance, this is a square. So if I'm explaining something in this vein, it will be a square. But if you hear like a triangle, we are not talking about a triangle, okay? Maybe I was just a bit carried away. And then this is 20 kilometers. 1 centimeter to 20 kilometers. So if you hear 1 centimeter to 20 centimeters, no, go by the notes, please. I could really use your help on that. Third thing, please beware of scammers, okay? As I'm saying it to you, I'm saying it to myself as well. The internet is a very big place. Somebody might ask you for something, for all you know, it's a robot or something, it's not even real. So just beware of scammers. If I don't say anything on this channel and somebody, an imposter, is asking you for donation or something, it's not me. Please don't fall for it. Recap. Okay, we look at drawing diagrams to scale in our last video. Okay, I'll encourage you to go and watch it. Okay, it looks simple, but at times a lot of students don't want to answer such questions, and those are questions that you can get for easy marks. Okay, now let's look at a quick example here. Using a scale of 1 centimeter to 20 kilometers, draw a square piece of land, okay, of 100 kilometers. So the land itself is 100 kilometers, but they are asking you to use 1 centimeters to 20 kilometers. So in reality, if 1 centimeter is 20 kilometers. 5 centimeter will be 100 kilometers. Okay, so you are going to draw a square of both sides of 5 centimeter, okay, by 5 centimeter. Now I use this ruler, okay, as you can see. So this diagram is actually to scale, so I use this ruler. As you can see, is centimeters. So I want 5 centimeters on both sides. So from here all the way there, you can see it's 5 centimeters. Now we've been told it's a square. So on this side as well, from here, okay, that is my ruler. As you can see, from one end to the other end. So from 0, okay, here, there to 5, that is also 5 centimeters. Okay, so what I did is I drew the first stop lines, and then I drew 5 centimeters to connect it. So this is what I have here. That is my square. Okay, now I wanted to alert you of something. So here you've been given a scale, you've been given the actual measurement, and you're asking to draw a diagram of scale. You can also be given the scale and be given the diagram. Okay, so they can give you this diagram, 100 centimeters by 100 centimeters. So they can give you this square and tell you that the scale is 1 centimeter to 20 kilometers. So now you might have to deduce that is 5 centimeter by 5 centimeter. Okay, so you can also be given the scale and the scale measurement, okay, and ask to find the actual measurement. Okay, so here you've been given the scale and you've been given the measurement and you've been asked to draw. Okay, so they can draw and say this is 100 kilometers and that is 100 kilometers. The scale is 1 centimeter to 20 kilometers. So you find out, they can say this is 5 centimeter to 5 centimeter and the scale is 1 centimeter to 20 kilometers. So you will have to work it out and say that, oh, if 1 centimeter is 20 kilometers, then 5 centimeter will be 100 kilometers in real life. Okay, so all what we've been doing, we've been using scale to draw diagram, but they can give you the scale down picture, and then they'll give you the scale to ask you to find the actual diagram dimensions. Okay, I hope you understand what I mean. Now today in our starter, we want to consider this diagram here. This is a circle, okay, and I use this compass to draw it. Okay, that is the north and that is the south, that is the east and that is the west. Okay, because I'm going to talk about bearing, I need to show you this, so I decided to bring in the starter. This part here is called the first quadrant. this word. Okay, quadrant, that word here. So that is the first quadrant, second quadrant, third and fourth. Okay, it's starting from 0 to 90 to 180 to 270 back to 360. Okay, so you know that the angle in a circle is 360. That is how clockwise. Clockwise is like if you have a clock, it goes in this direction, there and back there, and go back again and back there. This is anti-clockwise here. Okay, in the opposite direction of clockwise is anti-clockwise. Okay, now in pairing questions we normally use the clockwise. Okay, so we start from the north and measure clockwise. Is that okay? So having this at the back of the mind, I'm going to introduce you to bearing. Now, when we were looking at cylinders, you realize that some of the questions we're solving were things you already know. Okay, like to use the area of a circle, to use the circumference of the circle, to use the area of a triangle, the formula of the area. These are things you already know. So I've said to you, use what you know to find what you are asked to get or find the unknown. Okay, so at times when you are introducing topic, oh, it's like, oh, this is easy, I get it. No, maths is like a building block. Okay, you build from one stage to the other. So the chances are, if you can understand the basis and the concept and the principle, whatever is added to it, you'll be able to put it apart and answer it. Is that okay? So if you don't take the basic stuff easy, then that is where you get to a question and then you think, this is too complex, I do not get it. Okay, so that means you have to go back to the basis and understand the concept. Okay, now today we are looking at bearing. Okay, in mathematics, bearing is an angle measured clockwise. Okay, I've just shown you clockwise in our starter from the north. Okay, they are angles written in 3 figures. So for instance, you won't write 15 degrees as 1/5. You have to write 0.15 degrees. Okay, you are not going to write 30 degrees in a pairing question as this. It's 0.30 degrees. 90 degrees is 0.90 degrees. 140 degrees is already in 3 figures, so 140 degrees. 281 degrees is 281 degrees. Okay, now let's look at this picture again. Assuming this is a compass. Okay, now this is an example, but let me explain. So you have your north, you have your south, you have your east, okay, and you have your west. Okay, now if you look at the circle, you are bearing questions, you are going to measure clockwise from the north. So you are going to start from the north and measure clockwise in that direction that I'm going and back here. So this is why the north is classed as 0, 0, 0 degrees. So if you move down here and you know that this is the first quadrant, okay, so any angle from this north to the east is 90 because it's at right angles. Now the second quadrant, any angle between east and south is 90 degrees, 090 degrees, and 180 degrees. Any angle in the third quadrant is 180 to 270 degrees. Okay. Any angle in the fourth quadrant, okay, there are 4 quadrants, is 270 to 360. Okay, so if I'm being asked to find the bearing in this and the angle is here, straight away, because I'm measuring clockwise, I should know that my answer should be between 270 and 360. Okay, now keep that at the back of your head. Okay, now let's go on. Yeah, let's look at the question again. So here we want to find 040 degrees. Okay, so note, we have to measure clockwise, okay, from the north. So you need a protractor. Now look, normally you can use the double protractor, the 361 or the 181. Today I have the 181, so I'm going to show you what I did. So 040, it has 2 measurements. So I'll put this in the center here. Make sure it is on the line. Okay, now look at it. 040, so from the north, 10, 20, 30, 40, and it's exactly on that line. Okay, there. Okay, so that is my bearing from the north, 040 degrees, and you write it in 3 figures. Okay, so again, to stress that point, I'm measuring clockwise and I'm measuring from the north. That is the north. Okay, and from the north to the east is the first quadrant, which is 90 degrees. So straight away, if I'm measuring 040 degrees, that is 0 in bearings, it should be, so 040 degrees. I know that whatever I'm trying to measure should be in this quadrant here, in this place. Now, another example. Okay, I want to measure 125 degrees from the north. Okay, now you know that the angle in a full circle is 360. Okay, the first quarter or the first quadrant is 90. So as we have already said, 180, 270, and back to 360. So now, to measure 125 degrees, which is a 3 figure from the north, it should be in the second quadrant between 090 degrees and 180 degrees. So because I'm using this protractor, okay, I'm going to ask myself, what should I add to 90, okay, to get 125? Okay, so what I'll do is, I've been asked to do this. So if my circle is at right angles, okay, I can also just start from here, put this here, okay. So from 0 to 90, I want 125, okay. So 90, 100, 110, 120, 125 should be here. And you can see the line is there, which is 125. Okay, that's 130. So you can trace it already there. That is the line. Or what should I add to 90 to get me 125? 35. So I'm going to put it here. Okay, whichever way you try to do it, it is the same. Okay, but if you solve these questions a lot, you'll figure a way out to do it that is convenient for yourself and that is good at your learning, because we have different kinds of learners. Okay, so this is there. Okay, so now that is let me get it on the line again. You need to try and be as accurate as possible. So it's on the line now. No, it's not. Okay, it's on the line now, I think. Yeah. So 125 there. So that is the line 125. Okay. Or you can use this way as I showed you earlier. Okay. There, 125. Okay, so that is my line there between 120 and 130 there. And remember, this is already 3 figures, so it's 125 degrees, as you can see there. Now the third example here, okay, we want to find the bearing from the north to 250. Okay, now this is 180, so I need to add 70 degrees in this third quadrant and then draw the line. Okay, so my bearing will start northwise all the way here. So here again, I don't have a full protractor. In the exam, they might have some available, but if there is none and you are used to work with your protractor, protractor, you just use yours. Okay, because most mathematical sets at times do not come with that. Okay, so you can see from 180 so from 180 there, okay, and that is the line. Okay, so if this is 180, I want 250, so plus 70 will give me 250. So now my bearing from the north all the way around, remember we are measuring clockwise, that is my 250, and it's 3 figures. Okay, another example. So now the north, again south, east and west, and remember our measurement from 0, 0, 0, 0, 90 degrees, 180 degrees, okay, that's our south, 270 degrees, that is our west, and back to 360 degrees north. Okay, now we want 335. So you ask yourself, what do I add to 270 to get 335? Or what do I take away from 360 to get 335? Okay, I will go with the easiest one. Okay, so if I take away 25 from 360, so all I have to do is to measure 25 in the anti-clockwise direction. Okay, and that will give me 335. So again, if we use our protractor here, okay, okay, if we use our protractor here, that is 360, that is 10, 20, and the line here 25. So if I take 25 and I draw my line here, that will be all the way from here northwards, and that will be 335. Okay, so that is 335. Again, I've measured from the north clockwise 3 figures. Now let's look at another example. Okay, normally this is using the aviation industry to track air traffic and planes. Okay, so they can use this compass to say that's why some of the flights might be paused for a day, because maybe if there's too much airlines or planes at a certain location, it's just like the ground. If you are driving, some navigators can track and tell you there is a traffic here. So if you are traveling somewhere, they might try to find you an easier route to get there. So maybe there is a roadworks or something. Okay, so in the air, the aviation use some of these things to track and say to you that, oh, there are a couple of planes here, okay, and the weather is not good at this point, so we are going to hold this flight for maybe like 1 hour and see if something change, and then if things change, then they allow other flights. Okay, that's why at times, that is one of the reasons at times there might be delays. Okay, and then you can use the 180 as I've said, or the 360. Okay, I'll go and see if I can get the 361, but if I don't get it, it is like two of this combined. Okay, so there's one there, there's one there. Some of you might have one, but this is the 181. Okay, and you can also use it. I've always used this and I've not had any issues. Now let's look at our last example for today. Okay, now measure the bearing of a point A from O. So that is our O and that is our A. Okay, now what do? You draw a straight line between O and A. So this is, assuming it's a bigger circle, that is the point A. So you draw a line from the center O here to A. Okay, you measure the angle from the north in that direction, and you leave your answer in 3 figures. Okay, so now that is my point O from A. So if this is 90, I can measure. So a question like this, they might give you the drawing and ask you to measure. So I can measure from there to the line and subtract from 90, because that is my first quadrant. Or I can measure from north. Okay, can measure from the north. Yeah. Okay. There. And then to the A point here. There. Now you can see clearly that from 0 all the way, if you use the upper scale here, is 0. This is 70, that is 80, that is 75, nearly 75 from the origin. Okay, so if I'm measuring the bearing of O from A, then the point is 0.75 degrees. Okay, remember to leave your answer in 3 figures if you're working with bearing. Okay, so we've looked at intro to bearing today. The next time I come back, I would try and do some questions with you, and it might involve some of the angles we've learned, like supplementary angles and stuff. Okay, so thank you very much for watching today's lesson. I'll see you in the next.